Hello everyone. This is a presentation that I made comparing different technological advances among cryptocurrencies. This is not my field of study, but I find it interesting enough to put time on doing the analysis. So the first thing to understand is how Bitcoin works, because Bitcoin is going to be the baseline for other cryptocurrencies to improve upon. A simple transaction in Bitcoin contains an order that takes certain credit from one account, send it to a second account, might contain a message, and the difference between the amount of credit taken and the amount sent is going to be the transaction fee. And of course, this transaction is only valid if it's signed with the signature from which the credit is taken. Now, an individual might try to send all his credit to two different users and send that order to both orders to different sides of the network, somehow hoping that it will be able to spend the credit twice. And this is known as the problem of double spending. But of course, only one transaction can be valid. So to solve this, blockchain comes to place. In blockchain, transactions are clustered in a block and linked to the previous block of transactions. And all these transactions plus the previous block generates a problem that is computationally expensive to solve, and whoever solves the problem can broadcast a block and tell the rest of the network that the problem is solved and the block is generated. This is known as the consensus algorithm because it decides, solving this problem decides who is going to generate the next block. And a lot of computers trying to solve the problem means a lot of security. Because for an attacker to generate the block, it will be a lot more difficult. It will have to compete with all the network. Now, it is also possible that two different nodes of the network generate nodes almost at the same time. And only one of those blocks can be accepted. And the way to solve this issue in Bitcoin is for the network to only follow for each node to only follow the branch that looks like is generating the blocks faster. If the network is split almost 50% of the nodes in each side, it might generate multiple blocks before deciding which one is going to continue, but eventually one side will advance faster than the others and the nodes will start mining the longer branch of blocks rather than the shorter one. The blockchain works like a BitTorrent distribution. In the right side, there is a computer distributing a file through BitTorrent, and the way that it operates is that initially the server has the only copy of the file, and all the other nodes want a copy. So the server sends part of the file to two different nodes, and then those nodes become sharing the file. In this way, there is little need for servers dedicated to share files, because all the nodes are servers that share the files. Bitcoin works in a similar way. The blockchain is a large file, and it's shared by all the nodes on the network. An important concept is the digital signature. There are algorithms that produce pairs of keys, such that each key is one cryptographic number that can be used to encrypt and to decrypt. But the important thing is what one key locks can only be unlocked with the other key, and vice versa. In this way, one key is made public and available to everyone, and the other is kept private. The public key can be used by others to send us private messages, and the private key is not only used to unencrypt those private messages, but also to sign public messages. So by signing the message, only who has the key, the private key, can sign the message, and that's the way to prove that the owner is signing the message. In the case of cryptocurrencies, the messages are going to be the transaction orders. There is also in cryptocurrencies multi-signature accounts, which just means that one account have multiple keys associated, and to sign the transaction, multiple signatures has to be added to the message, and this will enable distributed exchanges. Now that the basic concepts of cryptocurrencies are clear, I would like to explain why it seems like Bitcoin is failing. Bitcoin have a problem with speed. It only produces one block every 10 minutes. It has a problem with scalability. Each block contains only 1 megabyte, have only 1 megabyte size, and that means that there is a limit on the amount of transactions that can be processed. And it's also badly decentralized because users group themselves in mining pools in order to make themselves more likely to succeed on the process of creating a block. And this means that a few mining pools control more than 50% of the computing power, and consequently a hacker could hack these mining pools and alter the normal functioning of the network. And one last point is anonymity. Bitcoins have anonymous accounts in the sense that the name of the owner is not associated to the account, but transactions are not anonymous, are public for everyone to review. By the time that I check the mining pools, 5 mining pools had over 50% of the computing power, and all these 5 are in China. So if we do something like running our national elections by broadcasting the vote over the blockchain, it would be possible for a foreigner government like the Chinese government to hack the network and prevent some of those votes or block some transactions. The nature of making transactions in Bitcoin, it allows some anonymity by shaking coins. For example, two users that have one Bitcoin in A and B could sign together an order of sending their coins to C and D, and both agree to sign the order in a way that an external user wouldn't know if the account C belongs to the same owner as A or as B. Now, many people don't see a problem with anonymity, but publicly making having our wealth publicly known could make rich users to become a target of crime, and for this reason it's not a good idea to have our finances publicly available for everyone, and anonymous transactions are an important issue. Now, there are other cryptocurrencies that have more advanced methods than just shaking. One is ring signatures. This method requires servers, and examples are Dash, Monero, Bitcoin, Phantom Coin. Monero is a bit special because it is compulsory for every transaction to be anonymous. In this way, there is no transactions that are publicly available to analyze and others that are suspicious of being money laundering transactions. All the transactions in Monero are anonymous, so there is no way to know where the money comes from. Now, this requires servers, and it is unclear to me if those servers could potentially leak information about the anonymity, the identity of the owners. Another more modern approach is zero-proof knowledge transactions, and the original two examples are Zetacoin and Zetacash. Zetacoin is older, and Zetacash is more anonymous because it's even anonymous the amount of cash, so it's even difficult to know how much cash is circulating, and if it was an error in the implementation, perhaps it would be more cash circulating than expected, and this would not be detectable. Now, I suspect that zero-proof transactions are a better choice because other cryptocurrencies like Ethereum already propose that they will implement zero-proof algorithms, and PIVX which already use a ring signature, announced that is going to move to zero-proof transactions. Another important innovation is what to do with the messages on the transactions, because these messages create a persistent public billboard that cannot be censored. Namecoin probably was the first one to make use of this technology and become a domain server in which users could use named coins to buy the domains and pay for the maintenance of the domain. Now, other cryptocurrencies capitalize on this by storing files, that BitTorrent files, which is difficult to store in public servers because it's usually illegal to help people to pirate copyrighted material, and consequently is difficult to have a dedicated server just to shared torrent files. However, it seems easier to store the torrent files within the blockchain of these cryptocurrencies like Emercoin or BitTorrent. And in this way, everyone who have a ledge of the cryptocurrency would have all these files. Other projects like Descent aim to capitalize by becoming a media platform. Descent have the capability of becoming a new Netflix, in which creators can publish directly over its network and use a similar system as BitTorrent to distribute their content, so they don't need to they don't need servers to host their content, but also to charge the users for reading their content by selling the keys to decrypt the content. And possibly the most important application is smart contracts that could be embedded on the messages. This allows users to have tokens that represent other cryptocurrencies or other assets. So technologies for smart contracts are Omni, the Omni layer that works over the Bitcoin by making use of these transactions. Next is another example with non-Turing equivalent scripts. Boost and Ethereum. Boost is older than Ethereum, but not as successful. And these two cryptocurrencies allow Turing equivalent code to be executed in order to. So a transaction is only valid if the script is executed as well. Byteball, it's a modern cryptocurrency but doesn't have Turing equivalent scripts, and this is based to the nature of its ledge, which is not based on blockchain. Now, most of the new cryptocurrencies all have smart contracts, because this enables to share digital assets that could be shares of a company, commodities. It could be the right to vote in a cooperative. Now, these smart contracts also have some issues. For example, the Ethereum network could be delayed because the nodes are processing too many smart contracts, and this delay would affect the transactions over Ethereum currency. OmniLayer does not have this problem because the Bitcoin network processes the Bitcoin transaction, and the OmniLayer have a separate set of servers processing the smart contracts. Liz have another alternative, and is to create side chains in which the smart contracts are for each application are processed on the side chains. These also have some issues, and the problem here is that the side chains have their own servers, and not all the nodes of the network are mining those side chains. And if a side chain have very few servers, it could be potentially vulnerable to hackers to hack that server, or maybe two servers, and take over the application. While in Ethereum, because all the nodes of the network have to process all the smart contracts, the whole network protects all the contracts and all applications over Ethereum. Another interesting innovation is to have a treasury, to keep a percentage of the transaction fees to pay for something else. For example, developers. Less miners means less security, but more services. BitShares was the first one to do this, but also Bushcoin and Ethereum. Bushcoin and Ethereum. Ethereum is a bit special because the fees are kept to pay for philanthropic projects, not for further develop applications to use its own currency. Also, other cryptocurrencies use part of these fees to pay for the master coins, the master nodes, which are making the transactions anonymous. Now, I would like to go back to the consensus algorithm because it's a very important issue on blockchain. The main algorithm, the first one, was invented by Bitcoin and is proof of work, in which the nodes have to use its computing power to solve the problem. The main issue with Bitcoin is that it's very expensive in electricity. It is said, I read that with the electricity spent to process one Bitcoin transaction, it could be power an American household for two and a half days. And this mining also requires a specialized hardware and cheap electricity. That's why the mining things go to the mining farms tend to be clustered in China, where the electricity is cheaper. But other cryptocurrencies also use proof of work algorithms. Litecoin was one of the first, one of the oldest cryptocurrencies, and tried to improve over Bitcoin by using another algorithm that does not require, that doesn't get an advantage for having a specialized hardware. In this way, it's more likely for other users to use perhaps laptops or personal computers to mine Litecoin rather than buying specialized hardware. Another idea is to use a proof of stake in which new blocks are not created by whoever solved the computational puzzle, but by those who have more currency. The more currency a node has, the more likely to create a new node. Now, in this case, it would be possible for a miner to mine two sides of the two branches of the blockchain in the case that they are created, and that's why currencies like Ethereum decide to don't go with proof of stake but to adopt a proof of work algorithm. However, other cryptocurrencies try to come with a solution by asking the nodes to put a collateral, and miners who try to mine two branches of the network simultaneously would are likely to lose their collateral. And examples of these proof of consensus methods are Peercoin, Next, and Blackcoin. Another method is delegated proof of stake, in which users choose to delegate the power to create a new block to a particular node. The first one was BitShares, but there are other cryptocurrencies like Lisk also using this method. And this is an important method because it's extremely fast, and these cryptocurrencies are successfully because they can process transactions really fast. Another way to do the consensus is by proof of importance, in which nodes who make more transactions are more likely to be selected to create the next block. And this is important because this is designed in this way because it's believed that more transactions mean more money being transacted means a healthier economy because the currency is moving. And this method in NEM would benefit those nodes who are spending currency. Redcoin come also with another idea, and is to reward the nodes who are actively sharing the ledge file. Therefore, in this way, new nodes in this way, it's easier for new nodes to be added to the network because they can get the file with the blockchain from many other nodes which are trying to share it in order to be able to create new blocks and get the transaction fees and the extra credit for creating those nodes, those blocks. Another way is another idea was to try to use the proof of work to do something useful rather than just wasting the electricity, like finding prime numbers, which could be used for cryptography. Primecoin was the first one, But Raycoin next year was released, which also aimed to find prime numbers, but have an algorithm which is better at discriminating fake primary numbers. Another possibility would be to trade computational time rather than spending. Gridcoin tried to reward donors of this network with Gridcoin is a platform to donate computing power to research projects, and this network rewards the donors with new credit created. The only issue is that donating computing power does not result into a consensus algorithm. MaySafe, also allowed to trade resources, is currently on development, so it's unclear how it works, but the idea is that everyone will be able to provide computing power or buy computing power and use the MaySafe coin of the network to pay or get paid for such services. Another innovation was proof of capacity, because proof of work is expensive regarding electricity. Proof of capacity adds an innovation in which the hard disk of the computer is used for mining, and this requires low electricity. This also means that users are likely to have hard disks that they are not using and decide to use this extra capacity for mining Boost coin. And farms are unlikely to mine to buy a hard disk only for the purpose of mining Boost coin, because lots of users would be using the extra capacity for free, in the sense that they are not investing on hard disk in order to mine. They just use the extra resources they have, and that would lead to a more fair distribution. This is the distribution of mining power for Boost coin, which it seems that over time is getting more and more distributed, which make a huge contrast with the Bitcoin distribution regarding the mining pools. Another way to solve the problem of deciding who creates the next block is by having a company owning the network and having its own servers operating. So in this case, there is no need for miners, there is no reward for mining, and there is there is less problem because all the nodes belong to the same network. The only issue is this is not the idea, this is not the dream of having bitcoins. The dream was to have a decentralized currency in which no private company owns can control the network, which might not be the case with Ripple and Stellar Lumens. This is going to be my personal opinion, and is the problem of reducing electricity might not be on the consensus algorithm, on the proof of work algorithm, but on reducing the reward for the miners, because miners will always increase in number as long as it's profitable. And I suggest that it doesn't really matter to have 1 million. 1 million miners is more secure than 1,000 miners, 1,000 nodes, but it's not a lot more secure. So perhaps this extra cash that is collected through the transaction fees is better invested on something else. Now I would like to talk about blockchain-free cryptocurrencies. The first one is to have an acyclic graph in which one transaction is linked to the previous and can only be linked if there is if both transactions are compatible with each other. Now, for the yellow transaction to be valid, all the red market transactions have to be valid. These new methods have no blocks, have no new credit created when a block is accepted, have no miners, no mining pool, so this problem of the network being less decentralized because the miners are clustering does not happen, and it also allows smart contracts. Examples are IOTA and Byteball. Another innovative network solution is the Safe Network. And this network have the capability of replacing the whole internet because the network offers servers, offers messaging, apps, emails, social networks, conference, and an attack on the network would require 75% of the nodes. In this system, users truly can exchange or mine hard disk and bandwidth for a coin. And there is no ledge, there is only a table of coins with the current owner and the previous owner. The coins can be splitted in this, and in this way the table could grow indefinitely, but it is expected that it will not grow as fast as the blockchain. Another important aspect with cryptocurrencies are the exchange markets. They are centralized and they are decentralized. The centralized markets, the users give the assets, the bitcoins, to the market, like in a bank, and the market keeps a fee that could be like a quarter of percentage from each one for a exchanging. Now, the dream of having bitcoins, which is a decentralized currency, is that there is no central computer that can be hacked. And the problem with centralized exchange is that they have a centralized system and a hacker could hack their computer and steal the currency. Mr. Goth was as exchange market founded in 2010, and in 2014 it was hacked and was more than $300 million in bitcoins were taken away. Now I'm going to focus on decentralized exchanges. The easy way is decentralized internal assets. And what I mean is that the smart contracts allow the currency to have virtual assets, and the blockchain can exchange those assets or tokens among users. Ether Delta is an example that works over the Ethereum network. And it takes about 0.25% fee on each transaction. The exchange could be decentralized externally. For example, Open Ledger make use of multi-signature accounts. So in this way, the network have multiple servers, and for a transaction to be valid, many of the nodes of the network have to sign that transaction. In this way, a hacker cannot just hack one computer of the network of the Open Ledger and take the resources away. Open Ledger works with BitShares. BitShares provides a blockchain to store the transactions. And it's an important technology to have a look because it doesn't have Turing equivalent smart contracts, but it has contracts that are optimized for building an exchange market. And unlike Ethereum, the exchange can handle as much traffic as Nasdaq, can process orders in a second. That means that BitShares could compete with credit cards in order to pay in shops. It have as basic tokens dollar and euro, which allow the system to make payments with stability, because it could be the network could send dollars with the same advantages of any other cryptocurrency, which is sending the currency anywhere in the world instantaneously. It also have bitcoins as internal asset. That means that Bitcoin users could deposit the bitcoins on OpenLedge and send bitcoins to each other through the BitShares account for less than 1 cent per transaction, which is virtually for free. The network is also designed to allow recurrent payments like a bank, and this would allow to pay for subscriptions. Other internal tokens are Ethereum, and another advantage is that users can have nicknames for their accounts rather than a bunch of numbers that are associated to the public key. The exchange takes no fees at all. It's completely free. The only cost of exchanging tokens are the cost of placing an order. which currently is less than 1 cent. So I can say that BitShares is cheap and secure, and certainly it have all the elements that I would choose if I wish to design my own cryptocurrency. Next, works on similar basis. Now, a more complicated issue is to a decentralized market that takes fiat currency like euros or dollars. And the way that BitSquare solves this is by matching not only buyers and sellers, but also an arbitrator, and make both of them to put a collateral online. So the buyer have to make a bank transfer to the seller, and the seller have to send the bitcoins or litecoins to the buyer. In this way, there is no centralized exchange market, but a peer-to-peer exchange market. In my opinion, the future of a single world decentralized currency is likely that it's not going to be Bitcoin or Ethereum. All the currencies that I paid extra attention have virtual assets or tokens. Bitcoin is unlikely to succeed because it's slow and is badly decentralized. In Ethereum is also badly decentralized because of the mining pools, but it's a lot faster. Like Bitcoin, transactions are not anonymous and is not optimized for sending virtual tokens. And this happened before that too many initial coin offerings for crowdfunding projects slowed down the whole network. So that means that the network do not scale well. BitShares also have tokens, and apparently doesn't have the scalability issues, even though it's based on blockchain. It doesn't have yet the problem of the mining pools because of the method of delegated proof of stake. And something important is that the transactions are so fast that the system could compete with cards in order to pay in markets. And the last two technologies, Byteball and the Safe Network, are special because are new technologies not based on blockchain. Safe is difficult to analyze at the moment because it's not implemented yet. It only exists as a virtual token that will become currency when the network starts working. But Byteball is completely decentralized, have no problem of mining pools because there is no such thing. And this technology has the potential of becoming the main replacing or leaving obsolete all blockchain cryptocurrencies. But again, if any of the cryptocurrencies based on blockchain is going to succeed, it looks to me like BitShares have the best system on the market. even though it's not transactions are not clearly anonymous as they should be. They should implement a zero-proof algorithm. And finally, I just want to say that for further details of these cryptocurrencies and further reflection, you could have a look on